In the early months of 1943, the industrial heartlands of the Ruhr Valley and the sprawling workshops of MAN in Nuremberg were humming with a desperate, frantic energy. Under the flickering glow of welders' torches and the deafening rhythmic pound of hydraulic presses, a new predator was being birthed. It was a machine designed to reclaim the shattered pride of the Wehrmacht and restore the myth of German technical invincibility. This was the Panzerkampfwagen 5, known to history as the Panther. To understand why the Panther was built, you have to understand the trauma of 1941. When German forces first encountered the Soviet T-34 on the road to Moscow, it was a moment of profound existential shock. The T-34's sloped armor made German 37mm and 50mm shells bounce like pebbles, while its wide tracks allowed it to glide over mud that swallowed the Panzers whole. For 2 years, German engineers worked feverishly to leapfrog the Soviet design. When the Panther finally emerged from the factories, it appeared on paper to be the pinnacle of armored warfare, a lethal fusion of protection, mobility, and firepower. The main battery. It was armed with the 7.5-centimeter KWK-42 L-70. This wasn't just a gun, it was a high-velocity sniper rifle for tanks. With a barrel length of over 5 meters, it could propel an armor-piercing shell at such incredible speeds that it could punch through the front of an American Sherman or a Soviet T-34 from over 2 kilometers away, long before the enemy even saw the muzzle flash. The armor profile. Unlike the boxy vertical plates of the Tiger I, the Panther utilized heavy sloping. Its 80mm frontal glacis plate was angled at 55 degrees, effectively doubling its thickness against incoming rounds. It was designed to be a frontal juggernaut, a shield that could lead the charge into the heart of the Red Army. The vision. German tank commanders were equipped with the finest lights optics in the world. The TZF-12A binocular telescope provided a level of clarity and magnification that turned the battlefield into a controlled environment. German propaganda, led by Joseph Goebbels, hailed it as the Wunderwaffe, wonder weapon. They promised the exhausted soldiers on the Eastern Front that a steel tide was coming, a machine so advanced that the Bolshevik hordes would simply melt away before it. But as the first shipments of Panthers arrived at the railheads near the front lines, the crews began to notice a terrifying trend. These weren't just sophisticated machines, they were temperamental, fragile, and dangerously volatile. Before they ever saw a Soviet shell, the Panthers were already earning a dark reputation. Behind the polished steel and the boastful radio broadcasts, a shadow hung over the Panther. In the tight, grease-stained confines of the hull, the men of the Panzerwaffe began to whisper a new name for their perfect tank. They called it a fire trap. When the smoke cleared from the early skirmishes of 1943, the reports reaching the high command of the OKH, Oberkommando des Heeres, were deeply disturbing. It was expected that a new tank would suffer losses in the meat grinder of the Eastern Front, but the nature of the losses didn't make sense. At first, the generals looked for the obvious culprits. They blamed the enemy. They assumed the Soviets had developed a new high-explosive anti-tank round. They suspected American-made Lend-Lease tank destroyers like the M10 were using secret high-velocity ammunition. They even theorized that Soviet partisan sticky bombs were being used in unprecedented numbers. But as the after-action reports filtered back from the maintenance battalions, the Panther crews, the data told a different, more haunting story. Panthers were being found burned out in the middle of open fields where no enemy anti-tank guns were positioned. They were found charred on the shoulders of roads, miles away from the nearest engagement. Most baffling of all, dozens of Panthers were catching fire without ever being penetrated. A Soviet 76mm shell might bounce off the Panther's frontal armor, leaving nothing but a silvery gouge in the paint, and yet seconds later the German crew would be scrambling out of the hatches as oily black smoke billowed from the engine deck. The anomalies continued to pile up. The idling inferno. During morning warm-ups, while the tanks were simply idling in their bivouacs to build up oil pressure, engines would suddenly erupt into flames. The steep incline disaster. When driving up even moderate hills, the strain on the engine seemed to trigger spontaneous combustions. The fuel lines were failing under the slightest pressure. The backfire menace. In several recorded instances, the act of the tank firing its own main gun caused the engine compartment to ignite. The very weapon designed to destroy the enemy was, in some strange way, destroying the tank itself. The German tankers, who were among the most highly trained in the world, were terrified. In a Tiger or a Panzer IV, if you saw a shell hit your armor and bounce, you cheered. You knew you were safe. In a Panther, a non-penetrating hit could still be a death sentence. The perfect tank was eating itself alive. The German High Command realized they weren't just fighting the Red Army, they were fighting a fundamental failure of engineering that was buried deep within the Panther's own guts. To find the source of the fire, you have to leave the muddy trenches of the Russian steppe and travel back to the frantic atmosphere of the German design bureaus in 1942. The hidden reason for the Panther's failure wasn't a single part, it was a philosophy of desperation. The Panther was a child of crisis. In late 1942, Adolf Hitler was becoming increasingly obsessed with a decisive summer offensive in 1943, what would become Operation Citadel, the Battle of Kursk. He believed in a massive, concentrated blow against the Soviet salient at Kursk would turn the tide of the war. To succeed, he demanded a weapon that could overmatch the T-34. He placed his faith in the Panther, but there was a catastrophic problem. The timeline. Normally, a main battle tank requires 3 to 5 years of development, rigorous testing, and teething periods to work out mechanical flaws. The Panther was forced through this process in less than a year. The engineer's plea. The lead designers at MAN and Daimler-Benz were well aware that the Panther was an experimental platform. They begged the Ministry of Armaments, headed by Albert Speer, for more time. They needed to test the fuel pumps, they needed to refine the cooling systems, they needed to stress test the final drive. The Führer's ultimatum. Hitler would hear none of it. He repeatedly delayed the start of Operation Citadel, not to give the engineers more time to fix the tanks, but simply to give the factories more time to build them. He wanted quantity over reliability. Because of this rush, the Panther was bypassed for the traditional trials phase. When the first 200 Panthers, the Aufsef D models, were loaded onto rail cars headed for the front lines, they weren't finished machines. They were essentially combat prototypes. The production lines were in a state of chaos. Engineering changes were being implemented while the chassis were already halfway down the assembly line. This led to a lack of standardization and, more importantly, a lack of quality control in the most sensitive areas of the machine, the engine compartment and the fuel system. As these 45-ton monsters unloaded at the railheads near Kharkov, the crews weren't receiving the refined weapon of war they had been promised. They were receiving a beautiful, deadly, but fundamentally broken experiment. The stage was set for the greatest tank battle in human history, but for the Panther, the battle had already been lost on the factory floor. The hidden reason was about to reveal itself in the most violent way. In the heat and dust of the Kursk salient. Panther's armor was its skin, and the 75mm gun was its teeth. The engine was its straining, overworked heart. To move 45 tons of German steel across the broken terrain of the Soviet Union, the Panther needed a power plant of immense capability. The engineers settled on the Maybach HL230P30, a V12 liquid-cooled gasoline engine. On a spec sheet, it was a masterpiece of 23 liters and 700 horsepower. In reality, it was a volcano waiting to erupt. The problem was one of physics and packaging. The Panther was originally designed to weigh around 35 tons, but as the design progressed, the armor was thickened and the gun was enlarged. By the time it hit the dirt, the tank had ballooned to nearly 45 tons. This meant the HL-230 wasn't just driving the tank, it was screaming at its absolute limit just to keep the tracks turning. The engine compartment was a claustrophobic nightmare of heat and pressure. Because the Panther was designed with a waterproof seal for fording rivers, the engine bay was almost entirely airtight. This was great for crossing a stream, but it was a disaster for thermodynamics. The airflow failure. In the dusty, sweltering heat of a Russian summer, the cooling fans struggled to pull enough air through the radiators. The engine ran significantly hotter than its design parameters allowed. Inside that steel box, temperatures would soar until the air itself felt like a physical weight. The proximity of death. Because space was at a premium, the fuel lines, carrying high-octane gasoline, were routed in terrifyingly close proximity to the exhaust manifolds. These manifolds would often glow a dull, cherry red during a march. Mechanical fatigue. Under the constant vibration of cross-country travel, the rubber gaskets and fuel line clamps began to vibrate loose. In an older Panzer IV, a small fuel leak might just result in a smell of gas and a stain on the floor. In a Panther, a single vibrating clamp could spray a fine mist of gasoline directly onto a manifold heated to 900 degrees. When that mist hit the metal, there was no warning. There was no engine light or buzzer. There was simply a muffled whoosh, followed by a wall of orange flame that sucked the oxygen out of the fighting compartment in seconds. For the 5 men trapped inside, the perfect tank had suddenly become a furnace. To modern observers, the decision to use gasoline in a heavy tank seems like a madness born of desperation. The Soviet T-34, the Panther's primary rival, ran on diesel. Diesel is notoriously difficult to ignite. You can drop a lit match into a bucket of diesel and it will likely go out. Gasoline, however, is volatile. Its vapors are heavier than air, meaning they linger in the low points of the hull, waiting for a spark. Why didn't the Germans just switch to diesel? The answer lies not in engineering, but in the crumbling logistics of the Third Reich. Germany was a nation starved of oil. Its entire war machine relied on synthetic fuel produced from coal or the dwindling supplies from the Romanian oil fields. The Kriegsmarine, the German Navy, had first priority for diesel to fuel its U-boat fleet. The remaining diesel was earmarked for the logistical trucks of the Heer. The Panzers were forced to use gasoline because the infrastructure for a diesel-powered army simply didn't exist in Central Europe. This fuel of necessity created a lethal feedback loop. The evaporation trap. In the overheated engine bays of a Panther, gasoline in the carburetors would often vaporize before it could even be injected into the cylinders, a phenomenon known as vapor lock. The explosion risk. When a Panther was hit by a shell, even if the shell didn't penetrate, the shock wave, or spalling, could crack a fuel line. In a diesel tank, this might cause a leak. In a Panther, the high-pressure gasoline would atomize, turning the interior of the tank into a fuel-air explosive. The lack of forgiveness. A gasoline fire is fast. It doesn't smolder, it flashes. If a Panther caught fire while the turret was traversed to the side, the driver and radio operator were often trapped. They didn't have minutes to escape, they had heartbeats. The German engineers knew this. They tried to compensate by installing automatic fire suppression systems, halon-like extinguishers that were supposed to trigger when heat reached a certain level. But these systems were complex, fragile, and often failed under the jarring impact of combat. The Panther was a high-strung thoroughbred being asked to do the work of a pack mule, fueled by a liquid that wanted to explode. While the engine provided the fire, the transmission provided the spark. In a design choice that would haunt German tank crews until 1945, the Panther's transmission was located in the front of the tank, connected to the engine in the rear by a long, heavy drive shaft. This transmission was a mechanical marvel of complexity, but it was tragically underbuilt. It had been designed for a 30-ton tank, not a 45-ton monster. As a Panther maneuvered through the thick, sucking mud of the Eastern Front, the stress on the gear teeth was astronomical. When a driver tried to turn the tank by braking one track, pivot turning, the torque loads would exceed the breaking point of the steel. The cascade of failure. First, a gear tooth would shear off. That piece of hardened steel would then be swept up into the rest of the gear train, acting like a grenade. It would shatter bearings and pierce the transmission casing. The oil fire. The transmission was filled with gallons of heavy lubricating oil. When the housing cracked, this oil, already heated by the friction of the failing gears, would spill out onto the floor. The final spark. As the gears ground themselves into iron filings, they threw off showers of white-hot sparks. If these sparks met the leaking transmission oil, or worse, the gasoline vapors drifting forward from the engine bay, the fire would start in the front of the tank, right between the feet of the driver and the radio operator. This is why so many Panthers were found knocked out with no holes in them. A driver would attempt to climb a small ridge, the transmission would catastrophically fail, a spark would ignite the oil, and the crew would be forced to abandon a multi-million Reichsmark machine because of a gear the size of a dinner plate. The Panther wasn't just a tank, it was a series of contradictions. It had the best gun in the world, but it couldn't always get to the battlefield. It had the best armor in the world, but it could be destroyed by its own fuel lines. By the time the Battle of Kursk began in July 1943, the Panther's reputation preceded it. Of the 200 Panthers deployed for the start of the offensive, many broke down before they even reached the jumping-off points. Some burst into flames while still on the transport trailers. The perfect tank had arrived, but it was a victim of its own ambition. It was a machine designed by geniuses, built by slaves, and commanded by men who were running out of time, leaving the young crews of the Panzerwaffe to wonder if their greatest enemy was the T-34 in front of them or the engine roaring at their backs. By the late summer of 1943, the prestige surrounding the Panther had curdled into a dark, cynical humor among the men who actually had to bleed inside them. The seasoned veterans of the Panzerwaffe, men who had survived the frozen hell of Moscow and the dust of the dawn, were no longer impressed by the sleek lines or the terrifying long-barreled gun. They had seen too many of their comrades transformed into human torches before even firing a shot. A culture of Panther survivalism began to emerge within the tank regiments. It was an unwritten manual of precautions born out of the collective trauma of watching perfect tanks spontaneously combust on the march. The extinguisher obsession. Officially, a Panther was issued with a standard internal fire suppression system. In practice, crews scrounged, traded, or outright stole every handheld fire extinguisher they could find. It wasn't uncommon to see a Panther entering battle with extra extinguishers strapped to the turret or stowed in every available crevice of the fighting compartment. The tactical march. Commanders began to refuse orders for long-distance road marches. They knew that driving a Panther for 50 kilometers at high speed was just as likely to kill the tank as a Soviet anti-tank battery. They moved in short, agonizing bursts, stopping frequently to open the engine hatches and let the heat dissipate into the Russian air. Social distancing on the battlefield. There was a chilling new rule among the armored columns: never park too close to another Panther. If one tank suffered a fuel fire, the resulting inferno was so intense, fueled by nearly 200 gallons of high-octane gasoline, that it could melt the rubber off the road wheels of a neighboring tank or ignite its fuel vapors. Veterans would later recount the psychological toll of this mechanical betrayal. In a Tiger tank, the crew felt like they were inside a fortress. In a Panther, they felt like they were sitting on a ticking time bomb. They developed a hyper-awareness of smells. The faint scent of raw gasoline wasn't just a nuisance, it was a signal to bail out. They listened to the pitch of the transmission gears like a doctor listening to a failing heart. The Panther could look like a king on the battlefield, imposing, predatory, and untouched, and yet it could become a hollowed-out furnace in the blink of an eye. The men didn't trust the machine, and in the high-stakes world of armored combat, a lack of trust is a precursor to defeat. As 1943 bled into 1944, the German engineering bureaus at MAN and Henschel worked with a frantic, almost religious fervor to exorcise the demons from the Panther's design. They were no longer designing a wonder weapon, they were performing emergency surgery on a dying patient. With the introduction of the Oust FA and eventually the definitive Oust FG, many of the Panther's most egregious sins were addressed. Redesigned cooling. Engineers added larger, more efficient fans and redesigned the radiator housings to prevent the heat soak that had plagued the earlier models. They added armored lousers to the engine deck to improve airflow while maintaining protection. The fuel line overhaul. The fragile, vibrating fuel lines were replaced with reinforced hoses, and the routing was moved further away from the blistering heat of the exhaust manifolds. Seals were hardened, and the carburetors were shielded from preventing vapor lock. Reinforced transmissions. While never truly fixed, the Panther's final drive remained its Achilles heel until the final days of the war. Later models used better alloys and more robust gear teeth to handle the 45-ton load. By mid-1944, the Panther had finally become the tank it was meant to be in 1943. It was reliable enough to sustain operations, and in defensive engagements like those following the Normandy landings or the Eastern Front's retreat, it was a terrifying opponent. A single Panther in a hull-down position could, and often did, decimate entire Allied tank companies, but the clock had run out. The Allied strategic bombing campaign was now pounding the German industrial heartland into rubble. The factories producing the improved components were being leveled. The ball-bearing plants in Schweinfurt were under constant siege. The refined steel needed for the gears was becoming a luxury Germany could no longer afford. Perhaps most tragically for the Wehrmacht, the teething years of the Panther had consumed their most precious resource, experienced crews. The veterans who could have mastered the refined Panther were mostly gone, burned in the experimental traps of 1943. They were replaced with teenagers with only a few weeks of training, boys who didn't know how to nurse a temperamental transmission or how to spot a leaking fuel line before it turned into a firestorm. The Panther had finally grown up, but the Reich was already dying. To look at a Panther today sitting in a museum is to see a triumph of industrial design. It looks modern, even by today's standards. It looks like it should have won the war. But the hidden reason why the Panther burned isn't found in a single faulty bolt or a poorly placed fuel line. The Panther burned because it was a victim of a political system that prioritized the aesthetic of power over the reality of engineering. It was a machine born of arrogance. Hitler and the High Command believed that German genius could bypass the laws of physics and the requirements of time. They believed they could force a prototype into mass production and that the will of the soldier would compensate for the failures of the machine. The Panther didn't burn because it was a bad design. It burned because it was an unfinished design. In the rush to meet the deadline of Operation Citadel, the Germans violated the first rule of armored warfare. A tank that cannot reach the battle is not a tank, it is a monument. The Panther was defeated by rushed engineering, a refusal to allow for a traditional 2-year testing cycle, fuel limitations, a strategic failure that forced high-performance engines to run on volatile gasoline, mechanical overreach, trying to cram a 45-ton capability into a 35-ton drivetrain, desperation, a system that valued miracle weapons more than reliable tools. In the final analysis, the Panther is the ultimate symbol of the Third Reich's wider collapse. It was a beautiful, lethal, and highly advanced weapon that was fundamentally broken at its core. It was a machine that promised total victory but often delivered nothing but a fiery death to its own people. The Panther didn't just catch fire because of gasoline, it caught fire because it was fueled by the desperation of a regime that was burning itself down, one perfect tank at a time.